started with me, but definitely.
Yeah, he's great.
Working.
Oh, just leave it and I'll check.
Okay.
And I'll put your kid in the office and then you pick up later.
Okay, cool, thanks.
Welcome everybody. This is the second talk in our Colloquium series. We're very glad to have Dr. Choi from engineering school. Dr. Choi, very experienced in robotics and in academic and also science work. That's good. And now he's having students here at Mercer in classes on the lab. So we're really glad to have the chance to have you come over and talk to us about the lab and student work.
Brilliant. Thank you very much for inviting us. We look forward to this opportunity to get to know each other and also possibly look for possible areas of collaboration. And I think we're so close and yet so far, and I think that needs to change. And I think this is a great opportunity where we can get to know each other. I think some of our students intermingle, but at the faculty level, we seem to not mingle as much. And I think it's a great opportunity to do that. And so, I brought a couple of my students. I'm sure you know them very well. They're both computer engineers, so they take quite a few classes here. So we'd like to introduce you to the Mercer Robotics Club and also the Machine Intelligence and Robotics Lab. Well, the club, which is the student organization, was formed fall of this past year, this academic year. The Machine Intelligence Laboratory, the Robotics Laboratory, was also formed at that time, at the same time. So these, the Machine Intelligence and Robotics Laboratory is the research wing, and then the Mercer Robotics Club is more the student interface group. And that's how we created the two together. They basically coexist together.
Alright, so I'm Nathan Burnham. I'm the chair of the Mercer Robotics Club, and Thomas Evans is the vice chair. And we're going to talk about it. So the Mercer Robotics Club is kind of, it's based for these things. It's a place where students can go to do whatever kind of student project they want to do. It's a knowledge base for if they don't know how to do mechanical stuff or electrical stuff or computer science stuff, they can get knowledge base from another student. Training in a couple fundamentals like soldering, stuff like that, and resources for parts if you need. And also we do a couple competitions.
Well, some of your training sessions were to learn how to program the Arduino and stuff like that. Yeah. So don't think like this. One thing that before we start getting into the deep end of this, one thing I would like to really focus and stress is the fact that robotics is a very wide field of study. I mean, very wide. So if you go to certain universities, robotics research lab is housed in mechanical engineering. You go to some other universities, robotics research lab is housed in computer science. Some research lab is in computer engineering. Some research lab is, in double E. Sometimes it's even in the physics department. I mean, it is a wide area of discipline. So that's why we think that robotics is an area where a lot of people and a lot of faculty come together and coexist and collaborate. So, don't feel like, oh, I'm not interested in soldering. We do a lot more than just soldering. Soldering is just a part. You talk to them, most of their project is based upon the software component, not necessarily the hardware.
engineers and mechanicals in engineering school, we can build dumb robots. We need the computer scientists got the knowledge of all the software to come in and put a brain on them.
Right. Well, one of the things we have in the lab is a laser cutter, and some of the web tech people saw some of that already. But so it can cut a ton of stuff and engrave a ton of stuff, and I don't know, it's a pretty cool tool, and people are welcome to come and use it.
And basically what this allows is if you guys have an idea in mind, if you want to program a helicopter, if you want to program a little car that's going to do something, and if you have a specific task in mind for it, but you know, this here show you that we can easily find the printout files for some kind of hardware online, print out your frame for your platform, and you're good to go. I mean, we already got a bunch of the software sensors, already got a bunch of the hardware, a bunch of sensors in the lab as well to help you with tasks like this.
Yeah, so
Temperature, force, light, sound, anything you can imagine, we've ordered it, we have it in there. And if you got some specialty parts, funding's available to buy those specialty parts for your tech. We have some higher level hardware. It's capable of quite a number of things. The Microsoft Connect has been big with the research recently. My project for the autonomous helicopter almost went with the Connect, and a couple other students in the lab have already picked up projects with the Connect, trying to do minority report stuff with it. The very first project I did was talking to the Microsoft Connect and rotating with an Arduino to give 360 degrees of range. But we have 3 or 4 of those in the lab. So if anybody's interested in doing that kind of stuff, the SDK and stuff's already loaded up on our computers, good to go. So if you guys just want to play. Some of our current projects we got going on right now. We just started up our robotics club this past semester, and basically how this goes about is you make a short, brief 5-6 slide PowerPoint presentation. You come in on one of our meetings, you present your project to the club. You get approved for funding through the club, there's no set funding. You just discuss it with Dr. Troy and the executive board. Depending on what you guys want, what you need to complete your project, we're more than happy to pay for it. But these are the projects that have picked up this year. International Air Robotics Competition is being done by my senior design team. That's the platform that we're using right now for our. It's a quad rotor helicopter meant to perform some autonomous task or mission. Nathan is working on
the autonomous lawnmower competition. So there's a couple versions of it. One that has dynamic obstacles and stuff, and you have to mow a lawn autonomously. And so we need some. It's going to be an interesting thing. There's an autonomous kayak project that another university has a fleet of autonomous kayaks on Lake Tahoe, and there's a lot of talk about improving some mechanical things about it, and also what software.
So basically, some of the projects, a lot of these projects, it seems like there's already teams made up and it's already done. It's not. The teams are open to new members. So if you feel like you want to be involved in the autonomous International Air Robotics competition, you're welcome to come and join in. The main members. If you become active members and so forth, then you will be able to get on the team, and therefore you will attend the competition yourself also. Okay? The autonomous lawnmower, there's a lot of stuff, but in both cases, you're talking about a tremendous amount of software that needs to happen. The helicopter is going to have 3 cameras, right? 3 cameras. Oh, you have another slide and stuff like that. So let me skip those 2 since we have the 2 team leaders there. But the idea is that those teams are open for new members and new people to come and join the team. And these will be platforms and competitions that we're planning to attend every year. It's not something that's going to end this year. It's going to continue on year over year. Autonomous Kayak is a possible research collaboration with Santa Clara University. They have a huge grant from the U.S. Navy to do certain types of clustering behavior algorithms with autonomous kayaks. And so what I'm trying to do is start up some sort of collaboration where we show them our certain capabilities to do things. So there are three parts to that. Is the mechanical, I guess, attachment device. That would be more like mechanical engineering. Another part is to actually have a fully functional autonomous bike built by ourselves that could seamlessly fit into their fleet and join their fleet. So obviously with that, you would need both the mechanics, you would need the electronics, and obviously you would need the software to control the autonomous kayak. And then the third part of that project is that mesh communication that you see, and that's literally purely software if you really think about it. The idea is that you create a mesh of these autonomous kayaks. Because of the range, not all of them will be in range with the other. So that means that you have to have self-healing networks, communications and so forth that's going on that automatically create their own routing tables and stuff like that. And I don't know how many of you are taking like networking and stuff like that. You have the experience like there, that would be a perfect place where you can come and immediately make an impact.
The 3D LED display was a project proposed by Nathan and James just for fun. Just as, hey, you've seen this done before, I want to build something similar.
We haven't seen it before.
Oh, okay, well, there we go. So projects are brought up to us through competitions that we find online. We try to build a robot for that. Just little cool fun projects we've seen online or just creative ideas that we members have had. Or the meteorite detecting robot was proposed to us by Dr. Marone from the physics department. And he has a group of people that always go out in the desert and try to search for meteorites. And he put a group together. He came in and proposed the project one meeting and got a group of interested students to do that for him. So there's many ways to get projects started up in the Robotics Club.
And the smart wireless automation.
Smart wireless automation, the concept there is I'm trying to build a simple rudimentary infrastructure of wireless devices that has low power, low cost in terms of implementation. And it will have very limited input and output capabilities, but it will be focused on being able to easily wirelessly connect with each other and preferably to a base computer. So I think right now we're in the process of looking at the Zigbee protocol as a infrastructure, and then you can create these modules for right around like $7, $8 maybe or so. Now then, once you have that, you can create daughter boards, cards that actually fit on top of that, and then you can put relays on there so that you can put it between your outlet and a coffee maker, and then you can turn your coffee maker from your cell phone. You basically connect to your home computer. Your home computer is connected to these, so therefore, as long as you have that connection, and which it can be done very easily nowadays, you basically can create cheaply home automation, home security, many different types of things. So one way to see a first iteration of something like this is if you go to MakeZine. It's a website on the, it's called MakeZine, like magazine is that instead of the mag, just put make in there. And search for automatic mailbox notification. And so once one person created, and he just wanted to know when a mail person comes and opens the mailbox door, puts mails in, he wanted to get immediate notification on his cell phone. Why? I don't know, but he did. So he created the circuit, he created the programs, and da-da-da-da. So there's that infrastructure, proof of concept there. So now I want to take that and then really get to the next level of things. And another thing is that, like that 3D LED project, not everything has to be research-based. Not everything has to have a goal. If it ends up that you learn something from the project, that is what we want. We want basically the Mission Intelligent Robotics Laboratory is built as kind of like a Tinker Lab. I'm not sure if you've heard the term before. It was basically coined at MIT. But the idea is to create a vibrant lab space with equipment, materials, and opportunities, and let students come in and play. If they want to play with this, software, there's some computers so they can write code. If they want to, make a circuit, there's a milling machine so they can, make a circuit. If they want to, make a little chassis, a little car, there's some, CNC milling machine so they can go and just